Good morning. So today we are going to finish up reviewing our systems of equations. So what I want us to do right now is to go over the one by substitution that we worked on yesterday. So we also do by graphing too. So, but I do just want to go over one that's by substitution. Okay. So solve this by substitution. To take about 10 minutes and do this one. Y equals negative 5x plus 30, and then 7x plus 30y equals 42. Okay, so solving by substitution, one of the equations has to be solved for the variable, which it is. So we're going to take this equation and we're going to plug it in the second one. So we're going to have 7x plus 3 times a negative 5x plus a 30 is equal to a 42. Okay, 7x minus a 15x plus a 90. Combine your like terms, so it's a negative 8x plus a 90 is equal to 42. Subtract 90 on both sides, so you're going to get a negative x is equal to a negative 48. Divide both sides by negative 8, so x there is going to be equal to a 6. So 6 is going to be the first point where they intersect. Okay, so now I'm going to take this number and I'm going to plug it in there. So I'm going to have y equals negative 5 times 6 plus 30. So negative 30 plus a 30, so that will be a 0. Okay. All right, I do want to do one more because I didn't really show you one yesterday like this, but all right. So if I wanted to solve this one by substitution as well, so let's go ahead and solve this equation for y. So that's going to be y equals, divide each one of those by 2. So 6x divided by 2 would be a 3x, 10 divided by 2 would be a 5. Okay, so I solved this equation for y. So basically I just divided everything by 2. Okay, so now I'm going to plug this in for my y here. So I'm going to have 3x minus 3x plus a 5 is equal to a 5. So I'm going to have 3x minus a 3x minus a 5, which is equal to a 5. So what happens to my x's? It goes away. So I'm going to be left with a negative 5 is equal to a 5. That is not a true statement. So this system has no solution. Okay. All right. So today we are going to talk about elimination. Okay. So elimination is where you're going to add or subtract your equations together. Okay. So solving systems by elimination. Okay, so when you do this, you need to make sure that everything is lined up. So variables need to be on the same side. And lined up. So make sure they're in the right line. Okay? You may need to multiply one or both of the equations. So multiply one or both equations by a number. Maybe a negative, I don't know, by a number. So one of the variables will go away. Okay? Okay, when you add and subtract, you want one of the variables to be eliminated. Okay? So when you add subtract you want a variable to be eliminated. Okay, you want to solve for variable. Okay, then you will plug what you got in number 4 in an equation from the beginning. Okay. All right. Let's do an example. Okay, so here, if I wanted to solve these systems here, I've got x plus 7y is equal to 17, and I've got x minus y is equal to a negative 7. Okay? Well, if I were to add and subtract these equations together, nothing is going to go away. If I was to add these two equations, x plus x would give me a 2x, 7y plus y would give me a 6y, so my variable is not going to go away. But what happens if I do subtract? Okay? If I do subtract this equation, okay, what's going to happen? I'm saying x minus x, which will be a 0x, right? 7y minus a negative y, so that's going to be a plus, right? So 7, so I'll be a plus an 8y. 17 minus a negative 7 there, so that's going to be a positive, what, 24? Okay, so what happened to your x? Your x variable went away, right? So now you're left with just an 8y. So now I can solve for y by dividing both sides by 8. So my y value is going to be 830. Okay? So now I need to get my x value. So I'm going to take this 3 just like I did and plug it in. Okay? So I'm going to have x plus 7 times 30 is equal to 17. So that's x plus a 21 is equal to a 17. So x is going to be equal to a negative 4. Okay? All right, so y'all do this one for me. Okay, so solve by elimination. So what happens if I were to add these two equations together? The two y's are going to go away, right? So 3x plus 5x is an 8x. 22 plus 42 is a what, 64? Divide both sides by 8, so x is going to be equal to an 8. I'm going to take that number and plug it in. So I'm going to have 3 times 8 plus 2y is equal to 22. So it's going to be a 24. Subtract, so it's going to be a 2y is equal to a negative 2. So y is going to be equal to a negative 1. Okay. All right, let's look here at one where we have to do some multiplying. Okay, so here I've got 7x minus a 6y is equal to a negative 53, and 2x minus 30y is equal to a negative 13. Okay, so those two would not go away, those two are not going to go away, but they are multiples of each other right there, so I could multiply this second equation by a negative 2. I'm going to do the whole equation, okay? So, not change anything about that first one. Stays the same. Remember, make sure your variables are lined up. Negative 2 times 2 is a negative 4x. Negative 2 times negative 3 is a positive 6y. Negative 2 times a negative 13 is a positive 26. Okay, so now what happens when I add these two equations together? So I'm going to get 7x, okay, plus a negative 4x, which is going to be a 3x. My 6y's are going to go away. And I have a negative 53 plus a 26, so negative 53 plus a 26, which is going to be a what? Negative 27. Divide both sides by 3, so x is going to be a negative 9. I'm going to plug negative 9 back into the original problem. Okay, doesn't matter which equation really you go to, but so 7 times a negative 9 minus a 6y is equal to a negative 53. Okay, so 7 times a negative 9 is a negative 63. Add, so negative 53 plus a 63, which will give me a negative 6y is equal to a 10. Divide both sides by negative 6, so y is going to be equal to a negative 5 over 3. Let's do another one. All right, so let's look at this one. So 5x minus 6y is equal to 3, and 7y is equal to 2x plus an 8. Okay, so those are not lined up, so I need to get these lined up. Okay, so I'm going to have 5x minus 6y is equal to 3, and I'm going to move my 2x to the other side, so it's going to become a negative 2x plus a 7y is equal to 8. Okay, got my variables lined up and my numbers. So now, if I were to add these two equations together, none of my variables will go away. 5x, nope. So now I need to multiply by something. So I can multiply this top row by 2, and I can multiply this second equation by 5. Because when I do that, then those two would go away. So 2 times 5 gives me a 10x. 2 times a negative 6 is a negative 12y. 2 times 3 is a 6. 5 times negative 2 is a negative 10x. 5 times 7 is a positive 35. And 5 times 8 is a 40. Okay, now if you were to add these two equations together, now what happens to your x's? Okay, your x's definitely are going to go away, so you're going to be left with a negative 12 plus a 35, which is a 23, and then 6, and that's going to be a 46. Okay, 46 divided by 23 will give you a y equals 82. Okay, you're going to go to the very beginning, one of them, doesn't matter, I'm going to go right there to that one. So I'm going to have 7 times 2 is equal to 2x plus an 8. So that's a 14 is equal to 2x plus an 8. Okay, subtract your 8, so you're going to get a what? 14 minus an 8, which is a 6. Divide both sides by 2, so x is going to be a 3. Okay. All right, so that is by elimination. All right. The next thing with solving systems of equations is using some applications. Okay, so applications are not going to go away. Okay, so applications define your variables. Okay. So we define your variables, then you're going to set up two equations. Okay? And then solve by the best way possible. Okay. So let's do an example here. Okay, so Marcy bought a total of 20 books and CDs during her yard sale. Okay, for a total of $54.50. I'm sorry. If books cost $1.50 each and CDs cost $5 each, how many of each did she buy? Okay. So take a minute, pause, and write this out. Marcy bought a total of 20 books and CDs during the yard sale for a total of $54.50. If books cost $1.50 each and CDs cost $5 each, how many of each did she buy? So take a minute. Okay, so what I'm going to do is I am going to let X be my books, and Y is going to represent my CDs because I'm buying two things. I have books and I have CDs. Okay? Well, I already have two equations set up. So my books plus my CDs are going to be a total of 20. So X plus Y is going to be 20. That's how many I'm going to have, right? But I also know the total amount of money. Okay? So my books are going to be $1.50, so that would be $1.50 times X. And my CDs are $5, so it would be $5 times Y. It's going to be equal to $54.50. So there's two equations there. Okay, I have one that has money associated with it, and then the other one, the total amount that I have, my total books that I have. Okay? So I'm going to solve this one by substitution because I think that would probably be the easiest. So I'm going to solve the equation for Y. So I'm going to get 20 minus an X there. I'm going to plug that in for my Y. So I'm going to have $1.50 X plus 5 times 20 minus X. Okay? So I'm going to have $1.50 plus 5 times 20, which is 100, minus 5x is equal to $54.50. So a negative 5 plus 150 is going to be a negative 350x plus 100. So now I need to solve for x, so I'm going to subtract. So 5450 minus 100 is going to give me a negative 45.5. And then I'm going to divide both sides by a negative 3.5. Okay. So x represents my books. So I'm going to plug 13 back in there for x. Okay. So I'm going to have y equals 20 minus 13. Okay, so 20 minus 13 there will be 7. Okay. So instead of being an ordered pair, that means I would have 13 books. And I would have 7 CDs. Okay? Good. So here you've got two things going on. You're just all you have is books and CDs. But some of the information that you have is just based on the total amount. Then the other one is based on the total cost, like the total amount that you spent. So the total books and CDs that you have together, and the total amount that you spent. So you had two equations there. Okay. All right, let's do another example. Okay. And then I think we're going to finish up word problems tomorrow. At the fast food restaurant, 4 cheeseburgers and 5 small fries have a total of 2,310 calories. 3 cheeseburgers and 2 small fries have a total of 1,330 calories. How many calories does each item contain? So take a moment and pause this video and write that out. Okay. All right, so first, I need to label my things that I have. I've got cheeseburgers and I have fries. So let's call that C for cheeseburgers. Let's call it F for your small fries. Okay, you have 2 things. So, 4 cheeseburgers. So 4 times C. And 5 small fries have a total of 2,310 calories, right? So 4 cheeseburgers and 5 fries have a total of 2,310. Also, 3 cheeseburgers and 2 small fries have a total of 1,330 calories. Okay? So there, now I've got my 2 equations, so I think that y'all could probably solve it for me. But let's do it together. Doesn't matter however you solve it, by graphing, by substitution, by elimination. I think this one would be the easiest by elimination because both of the coefficients have numbers, so it's not you can't really easily solve one of the equations. Okay? So I'm going to try to eliminate my C, my cheeseburgers. So that means I'm going to multiply this first equation by 3, and I'm going to multiply that second equation by 4. Okay? So 3 times 4 is going to give me a 12C. 3 times 5 is going to give me a 15. And 3 times 2,310 is going to be 6,930. Multiply here, so negative 12C. Negative 4 times this is negative 8. And negative 4 times 1,330 is a negative 5,320. So now when I add, my C's are going to go away. So I'm going to have 15 minus an 8, which is a 7. So I'm going to have 7 French fries and 1610. 1610 divided by 7 is going to give me a 230. Okay, so your fries are going to have 230 calories. Okay, but now I need to find cheeseburgers. So cheeseburgers, so I'm going to take this 230 and I'm going to plug it in one of those. Doesn't matter which one. I can go to the first equation or I can go to the second one. Doesn't matter. Okay, I'm going to go to the second one. So I'm going to have 3 cheeseburgers times 2 times 230 calories. Okay. Okay, so that's going to be 3 cheeseburgers plus 460 is equal to 130. You're going to subtract 460, so you're going to get an 870. So your cheeseburger's calories are going to be 290. So 290 calories in cheeseburgers. And 230 calories in small fries. Okay. Tomorrow we're going to review, so we are going to do a lot more application problems. Okay, so in your homework tonight for this, please just make sure that you work as many application problems as you can. At least get them, try to get them all set up and see if you get that part done correctly. Because that's a lot of times the hardest part. Okay, so tomorrow we will review all the ways to solve systems of equations and then applications. Okay, all right.